Okay, so here we go. Find the coordinates of a point on a circle with radius 10 corresponding to an angle of 65 degrees. Well, so again, let's draw it. Very important that we draw it. So I'm going to draw this circle. Okay, and put in the rest of the stuff here. Whoops, that is not what I meant to do. I didn't even know you could do that. Okay, so there's my circle. And now we're going to, it says it's a radius of 10, angle of 65 degrees. Now, where is the 65-degree angle? Do you know which quadrant? You can look if you're not sure. Here, let me go to our unit circle in our notes, which is not on my screen right now. Here's the unit circle. Come back up here. So from the notes, you'll have this. I encourage you to print this out, have this available. So 65 degrees, notice, is in quadrant number 1. All right, let me bring it back over here for us. So 65 degrees, here it is so 65 degrees is just past 60. It's about right there. 65 degrees, right? So it's clearly in quadrant 1. It's not past 90, is it? 65 is about right here. It's not past 90. It's in quadrant 1. Okay, so I'll just draw generally where that is. So let me do that. So I don't know, about right there. So I'm going to make this right here and this right here, and this angle. This is 65 degrees, about there, close enough. Okay, and it also tells us radius is 10. This is, notice, this is not the unit circle because the radius is 10, not 1. Are you tracking with me? It's a circle, but it's not the unit circle. Unit means 1, right? If people are united, they have one mind. So this is not the unit circle. This is not the radius 1 circle, right? This radius is 10, not 1. So I'm going to put a 10 here because that's what they told me the radius is. You'll have whatever number you have on your problem. So the radius is 10, not 1. This is not the unit circle. So you got to pay attention to that. That's tricky. We do so much with the unit circle, we can just assume, but they have specifically told us otherwise. The radius is 10. The radius, which means from middle to the edge, is 10, not 1. This is not the unit circle. This is radius 10, not 1. Okay, great. So what? Well, let's make our little triangle like we often do. I'll go over and up like that. There's our little triangle. And they want us to find the x and the y coordinates of that point, right? Find the coordinates of the point on the circle at an angle of 65 degrees. So this is x and this is y. Right? It's over x and it's up y. It's over x, it's up y. So we've got to use that to find the coordinates. So how are we going to do that? How are we going to go about finding those coordinates? So what we're going to have to do is, yeah, we can totally use SOHCAHTOA. That's a great idea. That's a great idea. Right, remember what we learned about SOHCAHTOA. SOHCAHTOA, right. Now, which side do we have for sure? We have the 10, which is the hypotenuse, isn't it? Because that's the side, here's the right angle. That's the side across from the right angle. So that's the hypotenuse. This side, the 65, the y is the opposite, and the x is the adjacent. Do y'all see that? So for this point, which goes over x, up y, that's how coordinates work on an axis system, right? You start from the origin, you go over x, up y. So this is x, this is y, and the 65-degree angle goes right here at the origin, and the y is the opposite side. The x, that's the adjacent side, and the 10 is the hypotenuse. So we want to use stuff involving the hypotenuse. So we're not going to use tangent because he doesn't have hypotenuse. Let's start with a sine, for example. Sine of 65 degrees. What is sine? Well, it says it right here. It's opposite over hypotenuse. And so that's opposite, y, over hypotenuse, which is 10. See how that's going to enable us to solve for y? Because it uses the opposite, which is y, and the hypotenuse, which we know is 10. So hit the buttons on your calculator. Make sure, again, that you're in degree mode. Sine of 65, I'm getting 0.9063 equals y over 10. And you remember how to do this, right? We put this over 1, go diagonal, diagonal. And so we get 0.9063 times 10 equals 1 times y. So 1 times y is just y. And I'm just going to, this is just answer button again, because that's the answer already on my screen. I'm just going to go times 10. I'm getting 9.063 for y. And they want it rounded to 1 decimal place. So that'll just be, cut it right here, right? 1 decimal place. That's 6 rounds up, 9.1. So y, I'll bring it up here, y will be 9.1. Now let's find x. So to find x, I'm going to use cosine, aren't I? Because x is the adjacent side. So the cosine, oh, probably don't have enough room there. Back it up a little bit. So the cosine of 65 degrees is adjacent over hypotenuse, which is x over 10, right? Because x is the adjacent, hypotenuse is 10. So use your calculator, cosine of 65, make sure you're in degree mode, 0.4226 equals x over 10. You remember we put this guy here over 1, go diagonal, diagonal, cross multiply. So we get 0.4226 times 10 equals 1 times x. That's just x. Hit the button. This is just the answer I have already on my calculator. So I just go times 10. I don't need to retype it in. And I'm getting 4.226. They want it rounded to 1 decimal place. So I put the line after the first decimal place. That 2 says leave it 4.2. So the x is 4.2. Bring that answer up there for 4.2. Here's the 9.1 answer for there. So we found the coordinates. We found the x and y coordinates of that point on the unit circle by using SOHCAHTOA, specifically sine and cosine.